Accordion is a platform that enables the deployment and management of next-generation applications. Those applications have stringent requirements with regards to the quality of their end users' experience. Among others, they require ultra-low latency and very high performance. It leverages the benefits of the use of edge resources and employs cloud resources on an if-needed basis. It often resorts to implementing mixed edge/cloud placement strategies that take advantage of the power of the two types of resources. The key idea is that edge and cloud resources are abstracted in the same way using an accordion construct referred to as mini-cloud. A collection of mini-clouds comprises the Accordion Federation, which is managed by a centralized platform called Continuum Manager. The Continuum Manager maintains a record of the available mini-clouds and their individual availability and characteristics and uses this information to deploy and manage application components in a way to optimize their performance and QoE requirements. The operations of the Continuum Manager are defined in abstract terms. There are three basic operations. Explicitly define the mini-cloud where an application component will be deployed. Implicitly define the mini-cloud where an application component will be deployed by selecting the one that meets certain QoE criteria. And undeploy an application component by explicitly defining the mini-cloud that hosts it. Accordion uses combinations of those basic operations to construct a more complex set of operations such as migration, scale-out, up, and restart. This latter set of operations are further complemented with monitoring mechanisms and QoE models tailored to the hosted applications that infuse runtime orchestration capabilities to the platform. An application model enables the developers to define QoE events that are relevant to their applications and a workflow of accordion operations that is required to be enacted for the dynamic mitigation of those events. A component referred to as Lifecycle Manager consumes the application model and reacts to the received commands by triggering the orchestrator to perform the expected actions. The orchestrator performs those actions after checking the availability and suitability of the underlying mini-clouds. The latter implies that apart from the orchestration of application components on top of mini-clouds, the Accordion platform incorporates other features too. One such feature is a distributed registry mechanism which allows large volume application images to be placed to mini-clouds that may require them or are close to those that may require them in the near future. Another feature is the SDK that Accordion provides, which enables application clients that are out of Accordion's control to inform the platform about their network connection characteristics. This information is crucial for the orchestrator to select appropriate mini-clouds to deploy the application components that are controlled by Accordion. Finally, an intelligent element of the Continuum Manager is using runtime monitoring data to estimate the probability of a failure in a resource that hosts an application component. In case of high probability prediction, it generates a QoE event to be handled by the Lifecycle Manager and the orchestrator. Accordion starts with addressing the needs of the providers and developers of the next-gen applications. Through its dashboard, it allows them to deploy their applications on a set of cloud or edge resources, taking advantage of the platform's mechanisms to optimize QoE provision. Accordion saves the users from the minutiae of the infrastructure operations, allowing them to define in abstract terms their QoE requirements. The users may opt between directly deploying or building their application components. We now present the process to be followed should the users decide to build their components before deploying their applications. Those users are required to be authenticated with the Accordion platform through the GUI and then push their code to the Accordion repository. The code must be accompanied by an application model, using an extended version of the Tosca syntax. The model describes the application components and their requirements. It also defines the acceptable QoE thresholds and the actions to be performed in case of a violation of those thresholds. Apart from the model, the image building instructions are required in the form of a Docker file setup in 3 stages: build, test, and production. Then, the users may log into the Accordion dashboard and create a new project. An Accordion project refers to the resources and the processes required to deploy and manage an instance of the application. A project consists of its name, the code repository, and an indication of whether the process includes the building or the use of pre-cooked images. In our case, it is a code-based project, and therefore, the building process must be initiated. Such a process includes a first step of validating the application model. Then, the building process starts. Finally, the testing stage is initiated through the test execution analyzer developed in Accordion. To complement that, a Trivy scan is performed to inspect the Dockerfile's base image to find unresolved vulnerabilities that the containers might inherit. The component is now ready to be deployed. To do so, a message to the Continuum Manager needs to be sent with the appropriate command. In this case, the command is an explicit deploy operation request. This operation is picked up by the Lifecycle Manager, who parses it and begins to collect the data required to formulate an orchestration-level operation. To achieve that, it starts with invoking the application bucket to receive the application model that is relevant to the application component at hand. This application model defines a single component application and the edge resources that are required to host this component. It further defines the actions to be performed by the infrastructure when a particular event takes place in relation to the component. In the example, the application model states that the game server component must be deployed in the mini-cloud that meets the resource requirements of the edge node and its QoE level is higher than 30. This metric is evaluated by the QoE model of the application component. It further defines that a low QoE event at runtime will be handled by the deployment of the component in another suitable mini-cloud. It then translates the application model to a Kubernetes-compliant deployment. This deployment instruction is then passed to the orchestrator. The orchestrator then checks the availability of mini-clouds against the resource requirements and whether they meet the QoE requirements and makes a decision about where to deploy the application. In this case, the decision is based on QoE models that rely heavily on network metrics between the application components that are out of the control of Accordion and the one that Accordion wants to deploy. A service developed by Accordion enables the collection of such metrics. An SDK for the application client polls the Accordion platform, allowing it to monitor, in near real time, the characteristics of the network that links each client to each available mini-cloud. The current QoE model uses that information to help with the selection of the mini-cloud. The particular one favors deployment in mini-clouds with a ping latency lower than 40 milliseconds. As such, mini-cloud 3 is selected. Then, the orchestrator uses an Accordion interface to the KES running in the mini-cloud that facilitates specific needs for command operations and return messages. Once the necessary command is issued, mini-cloud 3 deploys the component by following the Kubernetes deployment file instructions. It starts with fetching the component image, requesting it from its own image or VM registry. This local registry intelligently caches large images, so, if the image is stored locally, it simply uses it, otherwise it retrieves it from the centralized platform registry. Once the deployment is complete, the monitoring probes of the mini-cloud start reporting the data related to the containers that host the component. This allows the platform to list it under the running components. Now, We simulate a condition by which the pod running the component presents unusual load behavior. This abnormality is picked up by the proactive resilience platform component, and a QoE event is broadcasted. The lifecycle manager picks it up and checks the application model for the relevant mitigation plan. It then instantiates the plan in a Kubernetes deployment file which it issues to the orchestrator to implement. The plan includes the finding of the next best mini-cloud in terms of communication latency with the client. The QoE model sorts the list of the available mini-clouds and the orchestrator picks the next best option, i.e., the mini-cloud 1. This video demonstrated the ability of the Accordion platform to perform complex orchestration activities in order to meet stringent QoE requirements. We hope that you have found this video informative and that you will not hesitate to contact us should you have any questions or suggestions.